This is lesson 10.4, volume of spheres. To begin, I want you to watch this video on YouTube to illustrate volume of spheres and how it fits and how we can get the formula and everything. So go ahead and watch that video. I will insert it here, but just in case, it will be linked on my Canvas page as well. Okay, as we saw in the video, how much water was displaced? So once you put the sphere into the cylinder, how much water was displaced? How much was pushed out of the cylinder? So it was a third of the water was pushed out. Okay, to help us figure out how this is all working together, what is the volume of the cylinder? So a volume of a cylinder is the area of the base, so pi r squared, and then times the height, and that's going to be the volume of a cylinder. So for this particular picture, the height of this cylinder in terms of the radius, so we've got this cylinder is going to be 2 times r, and if you think about it, the sphere has got that radius and that radius. That's why the height is 2r. So we can actually rewrite that. Instead of pi r squared times h, we can write pi r squared times 2r. And so when we simplify that, we're going to get volume is equal to pi r to the third times 2. So that's just another way to write the volume of the cylinder. So to get the volume of a sphere, we're going to take the volume of the cylinder. Actually, let me write it like this. We're going to take the volume of the cylinder and we're going to take out a third of the volume of the cylinder because it displaced, when you put the sphere in, it displaced that. So whatever the sphere is taken up is going to be a third less. So if we have 1 volume of the cylinder, take away a third of the volume of the cylinder, what I have left is 2/3 of the volume of the cylinder. So the formula for the volume of a sphere, which is what's left in here, is going to be 2/3, and then the volume of the cylinder is the pi, well, I'll put the 2 and then pi r to the third power. And then when I simplify that, 2/3 times 2 is 4/3, and then pi r cubed. And that is the volume of a sphere. So one way that I use to remember that is I just remember that I've got these 2 3's, so I don't have to remember is it r to the third or r to the second. Also, it's r to the third because you have a 3-dimensional situation, so that's another way to remember it. But that's the volume of a sphere. So we're going to use that to find volume of several spherical models. Okay, example 1, the diameter of a billiard ball is 2 1/4 inches, so 2.25 if I'm looking at decimals. Find the volume of the ball. It says to use the pi button and round to the nearest hundredth. Okay, before you start, take your formula and you want to make sure that you have all the right information. So the formula for the volume of a sphere is 4/3 pi r cubed. And so if I look at what this says, it says the diameter. I don't want the diameter, so I need the radius. So I'm going to divide that in half. So make sure you have the radius and you don't accidentally use the diameter, because obviously that's going to make a very big difference. So I'm going to write this down on my paper. Please make sure you write it down on your paper before you put your answer. I don't want to just have answers. So once you put that in your calculator, you're going to round it to the nearest hundredth, and I use the pi button on my calculator. So what I see on my calculator is 5.964 and then some others. So I'm going to round that to 5.96, and that's going to be in inches. That's the volume. So if you're going to take a little cube that was 1 inch by 1 inch, it's going to take almost 6 of them to fill this ball. Okay, the next one, a grain storage tank is in the shape of a cylinder covered by half a sphere as shown. So if we look at this part, the cylinder part, okay, we're going to find the volume of that, and then we're going to add to it half of a sphere. So half of a sphere, if we take half of 4/3 pi r cubed, half of 4/3 is 2/3. So that's going to be my half sphere. And I'm going to add to that the volume of a cylinder. So that's pi r squared h. And so I've basically gotten this formula just by putting the things together that I know. So I'm going to do 2/3 pi, and then r is going to be 40 plus pi and then 40 squared times h, which is 50. And then if you're super careful, you can put all that into your calculator at one time. Okay, like I said, be careful. You could just do this part and add them together, of course. As long as you're using the parentheses and everything right, you should be okay. So what this comes out to be, I did use the pi button on my calculator, and so I get 38,536.6988. And so I'm going to round this to the nearest hundredth, so that's going to make that 9 turn into a 10, so it's going to be 0.7. Oh, it says round to nearest foot. Just kidding. So we're going to go, instead of 8, we're going to go 9 here. So 385,369 feet cubed. So that's a foot by a foot by a foot, those cubes. Kind of like if you remember the pyramid problem from the last lesson, that's how many it would take to put in there. So that's not as big as a pyramid, obviously, but that's a lot. Okay, let's go to the next problem. So if the volume of a sphere, so this time I'm giving you the volume, what is the radius? And so you can draw a picture if you want to, but it's really, just there's only one dimension we're worried about, and that's the r. So I'm going to have 4/3 pi r cubed, which I don't know r, but I do know that it's equal to 2304 pi. So it did say times pi, and that's, times 3.14 or so. So if you forget that, that's going to be a really big problem. So watch for that. So I'm going to solve that for r. So I'm going to start by multiplying by 3/4. And then I'm going to divide by pi. Okay, now when I divide by pi, that's canceling out. So I get r to the third power is equal to 2304 times 3/4. And so that's a pretty easy one to put in my calculator. And that's going to come out to be 1728. So I need to take the third root of 1728. So do you remember how to take the third root? If you have the third root of r, that's the same thing as r to the what power? Remember, power and roots, so 1/3 power. So just take 1728 and raise it to the 1/3 power. Put parentheses around your 1/3 in your calculator, and you should get that r is equal to 12. And so that's how many feet the radius is in that situation. So it's a 12-inch radius or 12-foot radius sphere. Okay, example 4. Two similar spheres. So that's like if you have a small ball and you have a big ball. And they're all circular, so all spheres are actually similar. Okay. They have a radius of 10 meters and 20 meters. So this is 20 and this is 10. And so r is equal to 10, r is equal to 20. So what is the scale factor of these balls? So if we do the first one to the second one in the order it was given, we've got 1 to 2. Okay, the second one's twice as big. The first one's half as big. Now it says, what is the ratio of their volume? So if you remember, actually let's go to C first. So we did area earlier a couple lessons ago. The ratio of the surface area, so if you're going to cover the ball, you're going to take the scale factor and you're going to square. So 1 to 4. So it's going to take 4 times as much paint or paper or whatever to cover the large sphere as it will the small one. Not just twice as much. It's going to be 4 times as much. The ratio of the volume, so how much will it take to fill each sphere? Like if you were going to fill each one with water, is it just going to take twice as much water to do the bigger one? Remember, you're going to take the scale factor and you're going to cube. So 1 to the third power and 2 to the third power. So it's actually going to take 8 times more water to fill that larger sphere, even though the radius is just twice as big. So remember that surface area is going to be a squared to b squared if your scale factor is a to b, and your volume will be a to the third to b to the third. 2 dimensions, 3 dimensions. Okay, we're going to continue the rest of this in the next video.